For this video, let's take a look at the antiderivative of 1 over x squared times square root of x squared minus 4, all in the denominator. All right, so for this problem, the technique that we're going to use is going to be trigonometric substitution. And the reason that I'm kind of clued that that should be to the technique is because of the square root of x squared minus 4 in the denominator. So in this case, the standard substitution to make is going to be that x is equal to 2 times the secant of theta. Now, why do I make that substitution? Because if I take a look at x squared minus 4, that'll be equal to 4 times secant squared theta minus 4, which is 4 times secant squared theta minus 1. And that's a trig identity. And so that's equal to 4 times the tangent squared of theta. Okay, so we've got everything lined up. We've got x is equal to 2 secant squared theta, so I'll substitute there. X squared minus 4, I'll substitute this whole thing here. The one part that I don't have yet is the dx, and so dx will be equal to the derivative of 2 secant theta, which is going to be secant theta times tangent of theta, d theta. And one other thing I probably should do before I get too far into the calculation is draw our reference triangle. So for our reference triangle, we see that secant of theta is equal to x over 2. And if you're like me, you don't think often in terms of secant, but you can think in terms of cosine. Cosine of theta is the reciprocal 2 over x. And so if I draw the reference triangle for this, here's theta. Cosine is going to be adjacent over hypotenuse, 2 over x. And so the other side here will be square root of 4 minus, square root of x squared minus 4. I apologize, by the Pythagorean theorem. And just so that we can see that the calculation here checked, so let's just do a quick check to see if this actually worked. The tangent of theta, according to the picture here, is going to be equal to opposite over adjacent, square root of x squared minus 4 over 2. And so that means that 2 times the tangent of theta is equal to the square root of x squared minus 4, or that x squared minus 4 is equal to 4 times the tangent squared of theta. And so as expected, these two lines match up that I have here. So what I have down here in black is not technically necessary, but I just want to do that here to confirm the trig identity that we used up here. Okay, so back to the calculation. We have the lines that I'm going to mark with stars are the things that I'll be using when I do the substitution. So this is going to be equal to integral of dx is equal to 2 secant theta times tangent theta, d theta, x squared, so 2 times secant of theta, whole thing squared. And then I have the square root of x squared minus 4, which is 4 times tangent squared theta. All right, so we get 2 times secant theta times tangent theta d theta, so the numerator stays the same. On the bottom, we have, well, we're going to have 4 times 2 makes 8 secant squared theta. And then the square root of of tangent squared will be absolute value of tangent theta. Now, ordinarily, I'd be stuck, except that I've rigged things so that with the definition of arcsecant, that the absolute value of tangent will always be positive. So I can get rid of those absolute value signs. And also, let me put a 4 down here. So 2 divided by 8 is a fourth. Yep. All right, now we cancel. So tangents cancel. Also, I'm left with a secant in the bottom. So I have 1/4 times d theta over secant of theta, which looks intimidating, except for the fact that the reciprocal of secant is cosine. So cosine of theta, d theta. So 1/4 times the sine of theta plus c. All right, so theta, I now need to convert sine of theta back to x's. So going back to the picture over here, I see that sine of theta is equal to opposite over hypotenuse. So square root of x squared minus 4 over x. And so I will use that down here at the bottom. So sine of theta, I just got done saying, is equal to square root of x squared minus 4 all over x plus c. And so that simplifies as square root of x squared minus 4 all over 4x plus c. And so that is the antiderivative of the original expression. Again, I can take the derivative of this to confirm that the derivative of what I just got here is indeed the integrand in what I started.